आज हम करेंगे कंजुगेट क्लास। कंजुगेट क्लास क्या होता है हमारे पास? कंजुगेट क्लास let A belongs to G, A belongs to G, then the set of all elements of G which are conjugate to A. Conjugate to A. रिलेशन में कह सकते हैं कि ऐसे एलिमेंट्स G के जो कंजुगेट set of all elements of G which are conjugate to A. Mathematically we can write X belongs to G such that X is conjugate to A. It means X belongs to G. X is conjugate to it means X inverse X is equal to Y inverse A Y. For some Y belongs to G. ठीक है, ये हमारे पास होगा कंजुगेट क्लास। नेक्स्ट हम क्या है इस बेस थ्योरम ऑन कंजुगेट क्लास। थ्योरम हमारे पास if G is a group, G is a finite group and A belongs to G, then number of elements conjugate to A is the index of the normalizer of A in G. That is, you have to do that order of it is equal to order of G upon order of N. ये हमें प्रूव करना है। इसके लिए हम by definition of conjugate class we can write proof we know that conjugate class of A is equal to X belongs to G such that X is conjugate to A and normalizer of A is equal to ऐसे ग्रुप के एलिमेंट जो A के साथ कॉमन करें A X is equal to A, उसको हम नॉर्मलाइजर ऑफ A कहेंगे। नॉर्मलाइजर ऑफ A मीन्स हमारे पास क्या होगा, जो इंडेक्स होगा इंडेक्स ऑफ एन A is the cosets of n in G. For this we have to prove that let A be the set of distinct right cosets Conditioning right cosets of an A in G. That is K is equal to an A as X belongs to हमारे पास it means we have to prove that order of K is equal to order of A. For this we have to prove that order of K is equal to order of class conjugate of A. Consider, for proving this we have to consider the mapping F from K to class conjugate of A defined by F of n A x, क्योंकि हमने जो एक जो सेट कंसीडर करके चले थे उसके अंदर हमारे पास एलिमेंट की जो फॉर्मेशन थी वो इस टाइप से थी, हमारे पास सेट ऑफ ऑल डिस्क्रीट हाइपोसेट्स ऑफ एन ए व्हिच इज इक्वल टू x इनवर्स ax। ये क्लास कंजूगेट ऑफ a, इसको हमारे पास कब हम इस मैपिंग को अगर हम वेल डिफाइंड कर दें, वेल डिफाइंड 1 1 and order 1 1 and order, so then we can directly say order of K is equal to order of class conjugate of A. First we prove that F is well defined. F is well defined. F is well defined. For this, let we have to consider two elements of K, NaX and NaY belongs to K, which are known. Then we have to take NaX is equal to NaY. We can write NaX y inverse is equal to Na. This implies xy inverse belongs to Na. This element belongs to Na. It means xy inverse is equal to xy inverse A. We have to multiply by x inverse and cross multiply by y. We can write xy inverse y is equal to x inverse xy inverse A y. यहाँ से हमारे पास क्या हो जाएगा, x inverse x A xy inverse y, which is equal to x inverse xy inverse A y. X inverse ax y inverse y, which is equal to identity x inverse x y inverse ay. This element is equal to identity and this product is also identity. X inverse ax is equal to y inverse ay. So we can write f and AY. So F is verified. तो हमारे पास क्या होगा वेरिफाइड. नेक्स्ट वी प्रूव दैट F is 1. Second we prove that F is 1. For this we have to take in F of NAX is equal to F of NAY. We have to take in two elements of K, let NAX and NAY belongs to K. Then we have to consider this. We have to prove that the NAX is equal to NAY. Then we can directly say that F is 1, which is equal to X inverse AX and Y inverse AY. And Y belongs to G and Y inverse also belongs to G, and here X is belongs to G and X inverse is also belongs to G. We multiply by X inverse X Y inverse and X Y inverse AY Y inverse. It means हमारे पास क्या है आइडेंटिटी पर होगा हमारे पास X inverse AX Y inverse which is equal to X Y inverse AY Y inverse. यहाँ से हमारे पास किसकी इक्वल है आइडेंटिटी के एलिमेंट तो AX Y inverse which is equal to ये आइडेंटिटी एलिमेंट तो X Y inverse A. ये हमारे पास तो हम लिख सकते हैं A into X Y inverse which is equal to X Y inverse A. यहाँ से हमारे पास क्या होगा तो X Y inverse बिलोंग करेगा नॉर्मलाइजर ऑफ A, क्योंकि ये A के साथ कॉम्बिनेट कर रहा है. तो X Y का inverse belongs to this. It means X Y inverse and A या and A राइट साइड पे अप्लाई कर सकते हैं और लेफ्ट साइड पे अप्लाई कर सकते हैं, which is equal to and A. यहाँ से हमारे पास ये किसी इक्वल हो जाएगा. दिस implies NAX is equal to NAY. तो मान यहाँ से हमारे पास क्या होगा हम कह सकते हैं F is 1. Next we prove that F is onto. F is onto. For proving this F is onto, we have to take in elements of superdomain. Let X inverse AX belongs to class conjugate of A, conjugate class of A, where X belongs to G and A is also belongs to G. So there exists and AX belongs to K such that F of NAX is equal to X inverse AX. So we can say that F is onto. F is 1 F is verified and F is onto. So this mapping F is bijection. जो हमारे पास F की मैपिंग जो हमारे पास F bijection हो गई हमारे पास and F and G is finite group and G is finite group. class conjugate of A is equal to order of K. ऑर्डर ऑफ K हमारे पास क्या है? सेट ऑफ डेसिमल ट्राइकोसेट्स ऑफ NaG, डेसिमल ट्राइकोसेट्स of Na in G, which is equal to index of Na. In G, we know that index of Na in G, which is equal to order of G upon order of normalizer of A, as this problem is